In this video, we are going to see the concept limits. Let's start with an example, a graph. Let's take the graph of this function. Let's say that x here, that it's equal to a. That the corresponding y value is equal to the capital letter of a. So to capital A. So if the x value approaches a, so that means if x gets closer and closer to a, so on the function you're for example here and you get closer and closer to a, you're for example here, you get closer and closer to a. So if x approaches a, then we can say that the y value approaches this capital letter A, and that is the limit. That is how we define limits. The capital A here is the limit, and the notation is, so the limit, we write it like lim, as x approaches a of f of x is equal to a. Okay, so the limit is a. This limit is not necessarily equal to f of a. So equal to f of a. It can be equal, but not always. We're gonna see that with some examples later. Let's describe the definition of limit in words. If x approaches a, so this value a, and f of x approaches capital A, then we say that the limit as x approaches a of f of x is equal to a. Okay, let's check some examples now. We have here the function f of x equal to x squared, and let's say that we are interested in the limit as x approaches 2 of f of x. So f of x is equal to x squared, so we are interested in the limit as x approaches 2 of x squared. If you look at the graph, 2 is here. Okay. We see that when x approaches 2 here, so on the graph we go closer and closer to 2, then we see that f of x approaches 4. You can see that here. So 4 is the limit as x approaches 2 of f of x. So the answer here is 4. Let's check another example. Before we check another example, in this case, a is equal to f of 2. Because f of 2 is 2 to the power of 2, which is equal to 4. But this is not always the case. You're going to see that in next example. So the following example, in this example, f of x is equal to x squared over x, which is actually a straight line that goes through the origin with gradient 1, but the origin is not included. Okay. let's look at the limit as x approaches 0 of f of x. So actually the limit as x approaches 0 of x squared over x. Okay, we can simplify this because we have x squared in the numerator and x in the denominator, so the squared here will cancel the x in the denominator. So that will equal to the limit of x going as x approaches 0 of x. And on the graph here we can see that when x approaches 0, so here on the graph when x approaches 0, the y value approaches 0 as well. Here. So the limit must be equal to 0. And that is also the case here. Because when you replace x by 0, that is equal to 0. So when we look at it graphically, then we see that the limit as x approaches 0, because when x approaches 0, we see that f of x approaches 0 as well. So we see graphically that it's equal to 0. And here we will calculating it algebraically. So the x squared, the squared, and the x in the denominator, they cancel each other. So we are taking the limit as x approaches to 0 of x, and that is equal to 0 because you replace the x to 0. And in this case, we see that the limit is not equal to f of 0. Why? Because f of 0 is 0 squared over 0, and it's undefined. So like you can see, it's not always equal to f of 0.